My name is Ian Belina. I'm an open source analytics sales evangelist with IBM covering the retail industry across North America. I've been in the software industry for over 10 years. I love software. I love data. I love being out there and evangelizing and spreading the great word of big data and showing people what's possible. Prior to IBM, I was a consultant at Deloitte for IT. Big data. What is the story behind big data? Right? Everybody keeps hearing the term big data. It's the new buzzword, but does anybody really know what big data is? What's the background of big data? So let's hop into the time machine and go all the way back to the beginning of big data. Right? Big data starts with Google. Yes, Google. Right? Google is a very famous search engine, but when Google was young, it was still growing, right? And there was tons and tons of data, right? Because Google's job was to go out there, scour the web, and index the web. So people can go out there and search and find anything out there online on Google. But the issue came about when data was growing so fast that Google, as a startup, could not keep up with it. Right? Because nowadays we have things like social media, where we have data from Facebook, from Twitter, Instagram, flight data, right? Data from all forms of life, essentially. And Google, as a startup, had expensive enterprise hardware, expensive data warehousing. And data was growing so fast that they could not keep up with it. It was not really cost effective. Then Google had an idea. They said, what about commodity servers? We have these cheap servers lying around. What if we were able to figure out a way to use this for production environment work, right? So Google had their engineers sit there and figure out a way to essentially get value from these commodity servers. The idea was, sure, we have this expensive data warehouse, but what if we get these 100 very basic commodity servers and we had them work together in parallel, right? So as opposed to having to run one job on one expensive server, we can just split that job up into tiny bits and pieces and have each commodity server run that job, right? So that's the idea when Google created something known as MapReduce. And Google ended up publishing this as a paper to the public. And from there, we then have to go to the story of Yahoo. So engineers at Yahoo saw the paper that Google published on MapReduce, and they ended up implementing that onto their production environment servers. And the change was drastic. It was phenomenal. To a point where Yahoo said, hey, you know what? Not only can we get value from this, but anybody out there should be able to get value from this. This is a very helpful solution for all enterprises. So engineers at Yahoo, one of them being Doug Cutting, ended up open sourcing this technology, right? So they got the paper that Google had, wrote the code for that, open sourced the code after testing it out in their Yahoo environment, and gave it to the Apache Foundation, and this became known as Hadoop, right? So that's the logo with the elephant. This was named after his, I think it was his kid's toy elephant, right? But that's where Hadoop was born. So now, whenever you hear the term big data, for the most part, we're talking about Hadoop. So what is Hadoop? Hadoop is reliable, scalable, distributed computing and data storage. That's a mouthful, right? But just think of it as Hadoop gets data, breaks it up into tiny bits, then has multiple computers compute and operate on that data, and then at the end, they piece it back together. So think of it as getting a puzzle, right? Breaking that puzzle into chunks, having different groups of computers solve each tiny chunk, as opposed to trying to solve the whole thing as a whole, then piecing it together at the end, right? This is valuable because you can get regular commodity servers, as they're called, and have them do things that prior were complicated and only expensive data warehousing could operate on. That's the power of Hadoop. All right, so once big data was born, then we had to move towards big data analytics because people had data, tons and tons of data, and they wanted to get insights from those data. So this starts with, for example, let's picture a chart, right? On the y-axis, we have value. On the x-axis, we have time, right? So as big data ended up getting bigger and bigger, for companies. For instance, if you're a retailer and an event occurs, in prior traditional systems, it would take you a while to truly take action on that event, right? So, for example, if somebody purchases something, it would take you a while to truly take action and say, okay, maybe we should upsell this person on this event, right? As companies were progressing and technology was getting better, they realized something, right? If we're able to take immediate action as soon as an event occurs, that becomes more valuable. We're losing money the longer we wait to take action whenever an event occurs, right? So this is where the use case and the need for real-time fast data and analytics on big data came about, right? Because they realized that some insights were perishable, right? So, for example, the longer we wait to operate or take action on something, the value decreases exponentially. So this can become a competitive advantage in terms of being able to take action on something as soon as it happens. This is where the birth of fast data was born. All right, so what exactly do we mean by fast data? Right. So going back to Hadoop, which is basically the foundation of big data, Hadoop consists of two parts: MapReduce and Hadoop file system. Right. MapReduce does the computations, the analysis, all the complex things, and Hadoop file system stores the data. But the issue with Hadoop was it was created at a point in time when it was cheaper to store data on disk as opposed to memory. Right. So and the issue with that is memory is a lot faster than disk. Think of disk as your filing cabinet, and think of memory as your desk on your cabinet, right? So it's a lot easier to do work on your desk as opposed to doing work from your filing cabinet, right? So Hadoop MapReduce was created using disk, but due to the increase in technology and the evolution of technology, it had now come to a point when it was cheaper and actually a lot easier. Well, not really cheaper, but a lot easier to store data in memory as opposed to disk. This is when Spark was born. So Spark is also an open source compute engine. So it's meant for data. It's made for fast data, right? So Hadoop was created for big data. Then Spark was the evolution of MapReduce, created for big data analytics and for fast data. Spark takes the advantages of operating in memory. So think of Spark as MapReduce, but it works in memory as opposed to on a hard drive or a disk. This is where it gets the phenomenal increase in speed. Right? So at its core, Spark contains essential libraries for big data analytics. Libraries such as Spark Streaming, which helps you in terms of processing real-time data, so fast data. So for example, if a company wants to run real-time fraud detection on credit cards, a use case would be for Spark with that. Machine learning. Spark comes with a built-in machine learning. So let's say you want to build a machine learning for your retail customers and you want to truly understand and evolve and learn and adjust in real time. This is something that's a lot easier to do on Spark. Spark SQL, being able to run SQL statements on big data via Spark. And lastly, GraphX, being able to do fast graphing computations. Now, the value of Spark, once again, comes from its speed because it operates in memory as opposed to on a hard disk. So, for example, running a logistic regression in Hadoop versus Spark, this is a sample chart, the speeds up, it just completely blows Hadoop out of the water. There's almost no competition. This is why Spark is really the greatest technology out there in terms of the big data space, where it's at the forefront of the trend, right? So companies like IBM are investing heavily in Spark because of this. So here's an example of a retailer that's using Spark. So in this case, Smarter Data, they're a retailer in California that they're able to leverage data science and predictive analytics with Spark. And they did that by being able, they wanted to find a way to find new ways to provide relevant and data-driven insights to consumer behavior. So they did that, or they accomplished that using IBM's Spark by being able to find contextual data to help retailers understand the consumer's behavior and what they desire. So as they're shopping, for example, being able to empower them and find insights in terms of what's driving sales, helping in-store teams provide smarter service to their customers in real time by leveraging contextual data to predict individual needs and create custom offers for those individuals as they're shopping. Right? So, for example, maybe somebody is in a store and they notice that. So going to the whole Internet of Things, having different forms of sources of data. If somebody's shopping, maybe to say they're in this section and they haven't purchased or they purchased here last month. Maybe we should offer them a coupon to have them purchase some more. So being able to react in real time based on different sources of information. And the cloud, right? So we have the big data, we have big data analytics, then we have the other buzzword, the cloud, right? So how was the cloud born? So the cloud was born from companies out there who had servers, expensive servers, but they weren't really fully being used the entire time, right? So, for example, imagine a retailer like Amazon, Walmart, right? If you see this chart here, the peak times in terms of traffic or transactions or whatever are essentially during Thanksgiving and Christmas season, right? So November, December, those two seasons. The issue comes about it in the sense that these companies, these retailers, or any other company for that matter, has to have hardware that can handle the load for Thanksgiving and Christmas, even though for the rest of the year, they barely have half that in terms of transactions, traffic, or whatever, right? So for the most part, besides Thanksgiving and Christmas, the rest of the year, that hardware is not being used. So it's not really cost effective for a company. So that then the idea was born in the sense that as opposed to paying for things that we aren't really using, why not only pay for what we actually use? Right? So you had companies out there like IBM, Amazon, who had tons of IT infrastructure. And they said, hey, what if we're able to rent out the space to other companies, to maybe a smaller company? That way they don't have to have this complicated IT infrastructure. They can simply rent from us or outsource to us, and we take care of the rest. This is when the birth of the cloud was born. Right? So the main premise now is either you buy or you rent the hardware, right? So think of cloud, you're basically renting hardware, right? So hardware is not really yours. You're basically outsourcing that part. So imagine your typical IT infrastructure. You have two options. Either you as a customer manage that infrastructure, or you get a service provider who handles the infrastructure. So in the traditional IT system, known as on-premise, the customer managed everything, the entire stack. So from networking, storage, all the way to data and the code. Right? So you have these multiple layers, and they're being handled by the customer. Then something was born called infrastructure as a service. This is where the customer decides to outsource their infrastructure to a different provider, right? Like IBM, for example, right? So, for example, with IBM software, you can outsource to a point where IBM handles the networking, the storage, the servers, and the virtualization, and you as a customer only have to worry about everything above that. So only the operating, the OS, all the way to the code. So examples are software, Amazon Web Services, Microsoft Azure, right? Then from there, other customers didn't really want to outsource that part. They wanted to outsource a lot more than that. So platform as a service was also born. This is when a customer outsources everything, including the OS, the middleware, and the runtime, and all they worry about is just the data and the code. So examples of this include IBM Bluemix for developers, where you're basically using services via IBM. So for example, Watson as a service, predictive analytics as a service, weather data, Twitter data as a service. You don't have to worry about the hardware it's being hosted on. You just worry about the service itself, right? So in this case, Twitter, you just worry about talking to Twitter and the service and the API. As opposed to having to worry about the OS, the networking, and all that different complex minutia, right? So that's the idea of platform as a service. Another example is IBM Compose, which is IBM's fully managed database as a service. So for developers who want to just outsource and not have to worry about running or hosting a database, just within minutes provision a database environment. That's an example of a platform as a service solution. And then there was software as a service. This is when the customer outsources everything to a vendor, right? And now all they worry about is just using and consuming the product. So in this case, it could be Watson Analytics, It could be data science experience, which is IBM's service for data scientists. So in this sense, the customer doesn't handle anything. All they do is just use the product. So in the sense, this is the birth of the cloud, right? So it came about from companies not really fully using up the entire hardware to a point where it's more cost effective to outsource it to a different vendor and just consume it as a service, whether it's infrastructure, platform, or software as a service. Then we had the hybrid cloud. This is one of the new innovations, and this is where IBM is betting heavily on, and this is where IBM is very well suited as a IT vendor. So, in the traditional sense, we had your traditional enterprise, where you have your data center. Then you also have something known as a private cloud. This is when the cloud. So, enterprise is basically just your typical on-premise, and private is when you as a vendor get a cloud, but it's hosted in your facilities. So, for example, it's inside your intranet, right? Not the internet, but the internet. So inside your internal network, where other people inside your company can access it, but it's closed off to the public. This is known as a private cloud. Then you have the managed private cloud, right? So all these are types of clouds. So the managed private cloud is when the cloud is private inside your company, but you outsource the management of that cloud to a different vendor. So it could be IBM, for example. So you basically have IBM inside your IT infrastructure that handles the cloud. They handle the infrastructure, right? So they handle the networking, the OS, the servers, the code. Everything is handled by IBM, but it's closed off to the public. It's inside your network, inside your company. Then you have the hosted private cloud. This is when the cloud is outside your network, right? So in this case, it could be with IBM outside your network, but it's private still, right? So it's not inside your network. It's hosted remotely. It could be, for example, in IBM's data center software in Dallas, Texas, so on a totally different country for that matter. But it's still being hosted by IBM and managed by IBM. Then you have the public cloud. This is where the service is available to the public. So it's not hosted inside your data center. It's hosted outside the public. The examples are IBM, Amazon Web Services. This is, for example, one of the downsides of this is you have something known as noisy neighbors. So, for example, a company or a vendor can have multiple people on the same server, where they basically virtualize and everybody has their own instance, but it's all on the same server. So this is the public cloud. Now, all this being rolled together into one is what's known as the hybrid cloud. Being able to fully integrate and go from each part of the cloud, each section of the cloud, is what's known as the hybrid cloud. So this is there for multiple use cases. So, for example, if a company wants to have part of its network on premise, part of its other network private but managed, and part of its other network or infrastructure public, right? Being able to manage all those different phases and different parts is what's known as the hybrid cloud. It's a combination of multiple types of clouds. A U.S. grocery store chain used analytics to find insights and help build a case to their executives for analytics inside the company. So in this case, they wanted to take their company to the next level using analytics and cloud computing as a way to convince their key stakeholders. They did this by being able to link weather data with people's grocery shopping behavior. Just think about that for a second, right? So imagine being able to find that the weather has an influence in terms of what people buy when they're shopping, right? So if maybe when it rains, they're able to realize, okay, more people buy beer or diapers or whatever, right? Or maybe when it's sunny, more people buy barbecue stuff, right? Being able to find the insights based on weather data that goes up to 30 years back, they're able to find lots of value from that. And this helped them in terms of this was half the cost, right? So everything was done in the cloud. So they didn't really have to provision the hardware. They can just simply start the POC in moments by just provisioning environment inside the cloud. It was 75% faster to build based on this being in the cloud. And they're able to convince their stakeholders and show the value of cloud-based analytics.